Hello everyone, I am the Korean PhD helper. Today is part 3 of the device series. Next, we will discuss of the data register D. The data register D device is a register used to store numerical data. It handles data with a sign bit with the most significant bit acting as the sign bit. Depending on the command, it can be either 16-bit or 32-bit. When using 32-bit commands, EX examples, demove, add, the negative, the increase. When using 32-bit commands, the N and the N plus 1 are both proceed. The N represents the lower 16 bits, and while the N1, the N plus 1 represents the upper 16 bits. Therefore, it is important to avoid overlapping in the area when using commands. For example, the move K1, okay, another numbers, K655360 D0, and the move K655360 D1. If D0 and D0 plus 1 overlap in the D1 area, data errors may occur. Okay. Data stored in the data register is initialized when the PLC power is turned off or the CPU is reset. However, data set in which areas are exceptions. This register is primarily used for operations, numerical processing, and the data management. So, it is very important to understand its characteristics thoroughly. Let us now discuss the index register G. The index register, also referred to as the general purpose operation register Z, so standard device register, is a device used for indirect settings, index modification in sequence program on index expression. Utilized one point of the index register, the method of use is as follows. First, specify D0, G0 if the content of G0 is 2. Then D0 plus 2 equal D2 becomes the target of the operation. Each index register can be used with a value ranging from -3 to 768 to 3 to 767. If values beyond this range are needed, the WZ register can be employed. Devices that cannot be used in expression include floating point E, string, FX, FY, FD. This is system devices, and point P, interrupt I, index G, and step S, and others. Share. We look at an example. Okay, first, create a move instruction as move D100, D0, D0, and let's assign any value to D100. Okay, let's go to simulations. Next, where input a value into Z0 index register, I will enter 5. Okay. G0 value is 5. Now execute the move okay, the 100 values. The 100 value, I will enter the 1 to 3. Okay, 1 to 3. The 100 into 1 to 3, and the G0 is 0, and G0 value is 5. Now execute the move instruction. The displayed value is that of the back, the 100. But shall I check the device monitoring? The 0. The 0 is 0. The actual value is input not into the 0, but into the 5. As mentioned earlier, since the content of G0 is 5, G0 is 5. Okay, I erase it. No, text this. Okay, D0 plus 5 equal to D5 becomes the target of the operation. Thus, index operators are mainly used in range specifications or for next statement. So please make sure to run them thoroughly. Okay, next we will discuss file registers and simulation of. The file registers are used as extension devices and can be proceed at the same speed as data register D. File registers can be configured as a single word 16 bits or double word 32 bit, similar to data register D. But the key difference is that file registers are allocated to a dedicated memory space called standard RAM. Standard RAM. Rather than device memory, the capacity limits vary depending on the CPU. For example, the Q03 UDVoid is 96 kilo and has a capacity of 1960 kilo, while the Q06 UDV CPU 384 kilo. These steps for registering a file register are as follows. First, OpenGX Works 2, and under PH parameter, PH file register. There are 3 options, each with the following characteristics. Number 0, non-used. Select this if file registers are not being used. And number 1, use the same file name as the program. Select this option when running a file register with the same name as the sequence program. However, as the use method is cumbersome, it will not be covered in this session. Number 2, use the following file. Select this option when one file register is to be used commonly across all programs. Select option 2, use the following file, and set the file register name and capacity. I entered file name is PyPy, capacity is this CPU is Q06UDV 344 kilo, and check again. Are you sure the set file register extended setting to or point D register and or point ratchet to? Yes. There's no error. Using the specified capacity, you can configure the number of points used through the file register extended setting by depending the start and device numbers. Device, file register extended setting, file setting, device number start, and device number end. This here. Okay. When using file register, two methods can be applied: R and GR. File register, R and GR. File register can be choose using either the block switching method or the serial numbers access method with the following difference. Okay, number 1, block switching format or method. File register, this method divides and assigns file register pointers in unit of 32 kilopoints starting from 0. Use the rset, K1 or K2, K3, Kn. Use the rset command to change the block number. Each block is assigned 32 kilopoints. For example, from 1, 0 to 32, 32767 R, and rset K2 blocks R0 32767. For example, and number 1, serial number access format. The method assigns file register exceeding 32 kilopoints with consecutive numbers. There is no rset command in this method, and device numbers from GR0 to the end can be used like this. Starting point is starting number is GR0 to GR393215. And next, we will discuss extended data registers. Part of the file register area can be used as an extended data register. The configuration method is so select only use the following file under PLC parameters, PLC file. This is here, file register. Next, in the device tab, set the usage point in file register extended setting here. Okay. 300 kilo device point and 84 kilos. D0. Okay, 0. This is device start number is changing D0 and device number and the 86015. First, note that internal user devices and extended data register D. Okay, register D do not share the same area, so avoid using sequential commands such as index, fmove, bmove operations. That's all for today. Thank you for your hard work.